This limit involves infinity, and you might be tempted to say that infinity minus infinity is 0, but we spoke in class about how that simply isn't necessarily true. So in order to make this a rational function, so we can compare the powers of x in the top and the bottom, we would like to use the conjugate. On the top and the bottom. By foiling, the numerator becomes x squared plus 25 minus x squared minus 1, and the denominator is still square root of x squared plus 25 plus the square root of x squared minus 1. We can simplify the numerator a little bit more. The limit as x approaches infinity, x squared minus x squared is nothing, 25 minus negative 1 is 26, over the square root of x squared plus 25 plus the square root of x squared minus 1. Now we can compare what's going on top and bottom, and let's look at the bottom here. To see what happens. We can do this two ways conceptually. Or algebraically. The algebraic method is to divide by the highest power of x in the denominator. And downstairs in the denominator we have the square root of x squared, or 1x essentially. So let's take that and divide by everything by x. Square root of x squared plus 25 plus the square root of x squared minus 1 divided by x and divided by x. This is a limit as x approaches infinity of 26 over x over the big square root. If I let this x slip in the radical, I can have x squared over x squared plus 25 over x squared plus this big square root of x squared over x squared minus 1 over x squared. Then the simplification is this, the limit as x goes to infinity of 26 over x over the square root of 1 plus 25 over x squared plus the square root of 1 minus 1 over x squared. 2. So once it's in this form, this term goes to 0, this term goes to 0, and this term goes to 0, leaving us just 0 upstairs and the square root of 1 plus the square root of 1, which is 2. 0 divided by 2 is still 0. We can't divide by 0, but we can divide 0 by stuff.